You guys, welcome back to my YouTube channel. Today we'll be dealing with clash, right? Advanced calculation. This is Mecano N6. Please, if you have not subscribed to my YouTube channel, yeah, subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new videos. So I have an example for you, which is example 1.2. Hence we did example 1.1 on a previous video. Please watch the video that is written introduction, clash plates Mechanotechnics introduction. I explained the uniform theory and one theory. I've explained this theory, weight theory and uniform theory, right? Uniform theories, those uniform theories, I've explained them, right? So without wasting of the time, let us indulge in our problem. So I give an example 1.1. The question that I read as follows says a single clash plate with a side effective, right? With both sides effective. If you know, when I talk about, I hopefully you if you did watch my previous video, you will understand when we had a single clash plate, the number of contact will be 2, provided with the both sides effective. I hope that you know that is required to transmit. This is power, as you can see. This is power, that is power, 130 kilowatts at, this is the number of 20 rests per second, the number of the speed there of rotation, right? The rotation speed. The outside diameter, we have given outside diameter of the contact surface is 380. This is big D. This is outside, this is big D. The coefficient of friction we've given. Then the uniform pressure. Here we have uniform pressure. This says here calculate the inner diameter, right, small letter d, of the friction surface, assuming we're dealing under what, uniform pressure theory. I said when you're talking about uniform pressure theory, we're dealing with new clashes, new or brand new. And then we said Rm will change this formula. We know, but we'll discuss as we are dealing with this question, answering the question. So here it's our single plate, guys. Here it's our single plate clash. As you can see, here it our, from here until there we have small radius, from there the top until there the bottom. As you can see, from there until here we have our big radius. So they said we should calculate the inner diameter. They say we should calculate the inner diameter. So if we can get the inner radius, if we can find the inner radius, then we multiply the inner radius by 2. Then we'll get what? The inner diameter, right? Remember, if we can find small letter r, we can find what? The inner diameter, because they said we should calculate the inner diameter. We can find the, let us calculate the inner radius, then we can find the inner, but you have to take some steps here. As you can see, here is the image of this single. This, as you can see, this is the friction surface, pressure is exerted there. Yeah, this is how it looks like. Let us answer this question. Data given. Let's check our data given. We are given that the diameter d is equals to, here we have given that diameter is equals to, okay, we've given power. Okay, let me just write that power. Let me take step by step. Power, which is equals to 130 kilowatts, and then n, it was 20 rests per watts per seconds. Here, as you can see there. Then The diameter is 380. You divide that by 1000, will be 0.38. This will be 0.38. It's an outer one. Is this diameter, an outer diameter. From here is this one, from here until there, until here is this one, the outer one. It is the outer diameter. That means the distance from there until down there. So yeah, you want is that you have given it, which is was 380 millimeter. So if you want the radius, we'll divide by what? By 2, right? If you divide by, this will be 190 millimeter. This R, the big letter R here. So yeah, so as you can see, you can find the radius, our radius. Divide this by 2. If you divide that by 2, you'll get that our outer radius would be 0.19 meter. This is in meter, remember. So yes, so we have coefficient of friction 0.4 and the pressure of 173 kilopascal. Coefficient of friction 0.4, then the pressure, which is 173 kilo. It was kilopascal. Yes, kilopascal. So we are done with our data. Remember, the aim is to calculate what? The inner diameter, right? The inner one, the inner diameter. To calculate the inner diameter is equal to 2 multiplied by inner radius. Supposed to have inner radius. So if you can calculate inner radius, then our problem will be solved. Let us calculate the inner radius. We know that our formula here is supposed to, the aim is to calculate inner diameter, which is 2 multiplied by R. So this is what we're supposed to find, this R there. So what can we do? We have given, with this formation that we have given, we have a power. Let us use the power first. Let me just say, can say solutions. Okay, let us apply power. We've given power. We know that power is equal to what? 2 pi nt. But if this it was in ref per minute, so we're going to divide this power by what? By 60. But now we know we've given n, which is equal to 20 revs per second, so we're supposed not to divide now. We should not, let us not divide. It will be like this from our equation. So we know that, let's calculate the torque. Make the torque, the subject of the formula will be P divided by 2 pi n. Then if you can substitute power you have given there, remember this is a pressure, then that is power 130 kilowatts. This is 130 times 10 to the power of 3, right? This is in kilowatts, right? Divide by 2 pi multiplied by 20, which is here. Our revs was what? 20. So this is what we have, guys. If you punch this, supposed to get this is simply equals to what? If you punch this, you may find that our torque is simply torque, right? If you punch this, will be a torque. The torque will be equals to 1034,507 is measured in newtons per meter. This is what we know so far. We have the torque. All right. Why did, in actual fact, why did I calculate this torque? Is because we know that the formula of the torque is equal to F axial, or we can, yeah, it's one and the same thing. You can say coefficient of friction multiplied by F axial multiplied by R M multiplied by number of this. So we know that the radius will find it here. But Rm, however, Rm they say will depend. Rm, that Rm or radial friction will depend on the type of the theory that you are given. It's whether you are given uniform wear, it's whether it depends whether you're given uniform wear or uniform pressure theory. Depends on the two. It won't be the same if you it will depend on these two, right? It will depend. If you're given let's say you're given uniform, which is this Rm will be equal to Rf, whereby is R plus R over 2. If you're given where theory we're talking about all things, but now we're given what they say according to uniform theory. We are not considering that that theory will be looking at what at uniform pressure theory, because they say it here, remember they say the uniform here, uniform pressure theory. As you can see there, they've just said uniform pressure theory. Then when we're dealing with uniform pressure theory, we know that Rm here will be simply equals to 2 over 3 into R cubed minus R cubed over R squared minus R squared. Is like this. As you can see, will be R cubed. Do not forget, do not make mistake here. It's R cubed, small letter R cubed, squared 2, like this. This is what our aim is, to calculate the inner diameter. I said what we want this little r. If you can find that r, then we'll be done with our question. Then we can solve our thing there if we can find that. So let us find this actual, but now we don't have this. I will advise you, if you don't have this, if there's a single unknown, if you don't have r or one of the two, it's either if you don't have r or you don't have r, please do not calculate it separate. Please do not calculate it separate. Substitute as it is directly in the formula. Do not use it separate. But if you are given two, if you are given both of these things, if you are given two of them, if you are given two of these things, you have given outer radius and inner radius, then you can calculate it separate if you want. But now, please, for you to make your maths so simple to save your life, substitute this as it is. We know our torque, we've calculated it, right? So we can substitute our torque here. It's our torque there will be 134 comma 507, which is equal to coefficient of friction, which is 0.4 multiplied by Fa multiplied by Fa. We don't have Fa, so let us calculate Fa. We don't have this axial force, so we can calculate Fa first. Let me just calculate Fa for you. Fa will be equals to pressure, right? Pressure mean multiplied by pi into r squared minus r squared. But or we can simply just say P is pressure multiplied by area. Then you know that area is this thing represent area. This is simply the area. Remember from our hydraulic and engineering N4, we have introduced that pressure it's equal to force over area. If we make F the subject, will multiply there, we'll have F equal to P multiplied by A. So it's one and the same thing here. But now area is this, our area of that will be pi is given by pi r squared minus r squared, right? So hopefully you understood this. Then if you substitute our pressure, it was we've given the pressure of 173 kilopascal, which times 10 to the power of 3. We've given it on our multiplied by pi. Our what was r, which was 0.19, if I still remember that squared, with now will be limited. Okay, we are not will be limited, so will be what, r squared. So let us not, let's take all of this, let's just take all of this as it is, right? Let us take all of this, do not simplify it, and substitute it here on our formula. We know our formula is what? Is torque is equal to coefficient of friction multiplied by axial force multiplied by our Rm multiplied by number of contacts. Okay, so we have a coefficient of friction which is 0.4 multiplied by the force. Substitute as it is. Just do not simplify it, leave it as it is because there is unknown. Just replace it as it is, times 10 to the power of 3 multiplied by pi into 0.19 squared minus r squared. So leave it as it is. What about Rm? We've calculated. We're supposed to use the formula for Rm. We said it's a uniform pressure, right? It's a uniform pressure. If it's a uniform pressure, our Rm will be equal to 2 over 3 into r cubed minus r cubed over r squared minus r squared. This is what we will have there. So let us just write it here. I want you to check some gymnastics there. So let us just put that formula there, because I'm supposed to multiply by it. So we know we'll use that formula. Rm will be multiplied by 2 over 3. We'll have r squared, r cubed. What is our big R, which is 0.19 cubed minus r cubed. We don't know r. This will be 0.19 squared minus r squared multiplied by the number of contact, which is 2. Remember, I said when you're dealing with a single, if you're given a single plate clash, your number of contacts of it will be 2. You must know this will be 2. There. So yeah. But here we have torque. This must be equal to torque. Let me just adjust this. Okay, I can adjust these, guys. I want us to make this math simple for so right. What, remember, this is this side. We have substitute on this side. What about the torque? We've calculated it. The torque, it was this. Well, here is the torque. We got it right. Our torque was this. This was the torque. So just substitute like this. I want you to check something. This 0.19 squared minus r squared. Also you have 0.19. Also here we have 0.19 squared minus r squared. Also here this is the same. We're multiplying this, and this will cancel nicely. This will cancel with this. This will cancel there nicely. as you can see. So if that cancel, will be left with 0.34507. Multiply all the constants times 173 multiplied by 10 to the power of 3 multiplied by pi multiplied by 2 multiplied by 2. Remember, we have 2 over, we have what there, 2 over, we have 2 over 3, right? So yeah, we have 2 over 3. That is what we have. So another thing, what can cancel again here? What will cancel again? If you check 2, okay, let me just multiply this as it is. 2 over 3 multiplied by 2. Let me just do it like this. This is what we have into this one, 0.19, like that. So yeah, this is what we have actually, right? This is what we have. Then okay, it's fine like this. This and that cancel. Yeah, it's fine. Then we'll divide by the, if you divide here both sides by all of this number of 0.4 times 173 times 10 to the power of 3 pi over multiplied by pi times 2 over 3 multiplied by 2. Divide by this both sides. Also divide by that side there, right? What I'm trying to say, why did I click? What I'm trying to say, you divide here, right? As you divide by this and this will nicely cancel. Yeah, obviously 0 there. That and that will be nice, will nicely cancel. Then so we have 134,507 divide by, just divide by that. Remember, you're supposed to divide both sides. This here will have equal 0.19 cubed minus r cubed. So then here we'll apply some math. We'll divide there, punch in the calculator. We'll simply have on our left hand side, if I punch them, I simply got 0.00357. Then I punch this 0.19 cubed. This will simply equals to 0.00686 minus r cubed. Then is math. I'll just say r cubed. I take this to the other side, will be equals to what? 0.00357 minus 0.00686, right? Then cubed. I take cubed. I take the cubed both sides, square root of cubed. This and that will cancel. I'll have r. Then here we have 0,00357 minus 0,00686. Then as we punch this, we're supposed to get that our r. If you punch that accurately, what is r is 0,148 meter. Remember radius, but they said we should calculate the inner diameter. They wanted the inner diameter, so the inner diameter I said is 2r. This will be 0,148. Then multiply this, we'll get that will be 296 millimeter. No, won't be millimeter, sorry about that. If I can multiply this by 1000, example, maybe I'll make, maybe our r, if I multiply, our r will be 148, right? So if I want it to be in meter, I can simply put 148. For an example, this will be 296 millimeter. This is what it is, guys. Thank you for your time. Thank you for your patience. Thank you for watching. Thank you, guys. Please do not forget to subscribe to my YouTube channel and share this video. You can also comment. Yeah, this is what steps that we took, necessary steps supposed to take to get to the final, your final answer, right? This is what you're supposed to take. Thank you, guys. Subscribe and share this to your fellow classmate. If you feel free to comment, and feel free just to comment and like the video. Sharp. See you on the next comment session, right?